This 6040 CNC was purchased 2 years ago and it has been running without a problem. Easy, simple and straightforward to assemble. Next to the ER20 collet, a wood clamp holds a vacuum nozzle to pick up more or less 90% of the wood dust. The CNC sits on a stable and sturdy surface. The spoil board has threaded wood inserts, one in the center for round pieces and 4 additional ones for lateral plywood clamps. The 2.2 kilowatt spindle is very quiet and does not vibrate at all. There is a side view of the CNC and table. Under the CNC is the VFD and PC that drive the CNC with the help of Mach 3. When I purchased Mach 3, I was a little lost and did not know how to make it work, but thanks to the other YouTubers I found the UC100. The UC100 people were very helpful. The CNC manufacturer sent a good explanation how to program Mach 3. As a beginner, I still was a little lost, so I contacted Mach 3. Oh man, these people are very helpful, and finally my CNC was working correctly. This water pump is a very noisy puppy, but it works well. I transferred the German Eagle from the internet and trace it in AutoCAD using line, arches and circles. Don't use splines. And hatch the areas that needed cleaning. It means removing material. The hatching helps us to see how the eagle is going to look like when we can, and then we can save it as a DXF. I discovered F-engrave thanks to other YouTubers. Transferred the eagle as a DXF to F-engrave, and as a starting point I selected the center of the image. You can set the height, the image center and the feed rate. Go to settings and enter your tool dimensions. Click VCarve and F-engrave will let you know if your drawing has problems like interrupted, overlapping lines, etc. by showing you an irregular shape where the problem is. This is a capable software and generates a G-code for milling. On Mach 3 you center your pattern and set the CNC to 0. You go to Toolpaths and Simulate Program Run. In this case, it will show you 21 minutes. Go to Program Run and start the CNC. And don't forget to rewind. On Toolpaths shows you the progress of the tool. The green arrow indicates the Z axis. I'm not going to record the whole length so that the video turns a little bit shorter. I did not take a video during the making of the eagle. Sorry about that. The milling of the German eagle is ready, and a 60-degree milling bit at 10,000 RPMs and 350 millimeters per minute and 3 millimeters depth were used. We go back to F-engrave and now we calculate the cleaning. That means the hatched areas around the eagle with the 1/4 of an inch straight milling bit at 15,000 RPMs and 350 millimeters feed and 3 millimeters depth, and an overlap of 50%. Parallel to the x-axis, and click Calculate Cleaning. The yellow strip below indicates that the program is working. The red lines show the cleaning bit path. Small areas are left untouched because the milling bit diameter is too large to access these areas. We load the cleaning in Mach 3, set the new tool and coordinates to 0, go to tool path and calculate the cleaning, and see that is almost 20 minutes here. We rewind and start the cycle in the tool path, and we can see how the tool is cleaning the eagle. We go to tool path and notice the green arrow simulating the up and down tool movement. The coordinates show where the spindle is cleaning the eagle. We are gonna make it a little bit shorter, so we will stop Mach 3 to avoid again a lengthy video. Once the milling and cleaning were ready, I had to do some cleaning with a wood chisel because MDF sometimes does not clean very well. And you see it's a little bit of gunky material on top of the eagle. After the cleaning and repainting where the MDF fibers ripped, I proceeded to apply polyurethane to give it a little sealing and a better appearance, and now the eagle is ready. I hope you enjoyed the video, and thanks for watching.